Hello students, and welcome to our lesson on the AC method. This is going to build on our lesson about factoring using GCFs and grouping, because factor by grouping is a part of the process to use the AC method. So first, quick review. Factoring is the process of writing one polynomial as a product of two or more polynomials. It is the inverse or reverse of multiplication. So what we're going to do in this first example is multiply these two binomials together by distributing and then simplifying. And what we're going to see in this lesson is that factoring is the exact opposite. It'll take us the other direction. So if we were to multiply these two polynomials together, I would distribute the 2x to both the 3x and the negative 4. So I can write that as 2x multiplied by 3x minus 4. And then I would add to it the 1 distributed to the 3x and the minus 4. So 1 in parentheses 3x minus 4. Notice that this looks like one of the steps in factor by grouping, where we have the 2x and the 1 are in front of each set of parentheses, and the two sets of parentheses are the same. If I now distribute that 2x, I'm going to get 2x times 3x gives me 6x squared. 2x times negative 4 is negative 8x. And then on the other set of parentheses, distributing the 1, I'm going to get 1 times 3x is 3x, and 1 times negative 4 is just negative 4. So from that step, those two that are showing there, we can see that factor by grouping would take us from 6x squared minus 8x plus 3x minus 4 up to the binomial multiplication at the top. But usually we're not going to be given 4 terms the way that bottom line is written. Instead, if we add together those middle terms, we have 6x squared minus 5x minus 4, where we actually only have 3 terms now. So what we just did was multiplication, right? We went from the top to the bottom by multiplying. What we learned in the previous lesson is how to go from the third step row up to the top. So that green arrow, that is factor by grouping. Okay, we learned that in the previous lesson. But there's one extra step that we're going to add on to this, which is to go from the bottom one to the start of that green arrow. This is going to be the AC method. And the AC method is also commonly called splitting the middle. The reason splitting the middle is a name that makes sense is notice that negative 5x splits to become negative 8x plus 3x. So what we're going to be learning today is not factor by grouping, okay? We already learned how to do this green arrow right here, which takes us from the 4 terms up to the top. What we are specifically learning is how to split this middle term into these 2 terms. We will then do the factor by grouping steps to get all the way up to the factored form at the top, but this lesson is specifically about splitting this middle term into these 2 terms you see above it. That way we can apply factor by grouping. But that's the only new thing we're going to learn in this lesson. So we're going to do a lot of examples where we're mostly just practicing factor by grouping again. But the key to the lesson really is splitting negative 5x in a negative 8x plus 3x, where notice those are equivalent. All right, but so now, how are we supposed to know that negative 8x plus 3x is the correct way to write negative 5x to allow us to factor by grouping? Because these two numbers here are not chosen randomly. Yes, they do add together, negative 8x and 3x, to give me negative 5x. That is one component. But the other component of how we split it is notice that negative 8 times 3 is equal to negative 24. And where else can we get negative 24? Well, if we multiply 6, well, let me wait for that to go away. If we multiply 6x squared times negative 4, ignore the x squared for a second, 6 times negative 4 is negative 24 also. So there's two things going on here. We need negative 8 and 3 to add together to be this negative 5 that's below it. But we also need negative 8 times 3 to be the same thing as 6 times negative 4. So there's two pieces of a puzzle. All right, let's see that formalized in the bullet points down below. In order to factor using the AC method, we are going to multiply the first and last terms. So we're going to multiply the A, which is the first term, or the coefficient of the first term, and we're going to multiply that by the C, which is the coefficient of the last term. Okay, so we're multiplying the A and C numbers, which are the coefficients or the constant in the back. So as a quick reminder here, when we have a problem that is in standard form, for a quadratic anyway, we have ax squared plus bx plus c. So we're specifically talking about this a in the front and this c in the back. And that's how we get the name the AC method, is we are using the a and the c to inform us of how to split the middle term. So we multiply the a and c together. That is step one. Then we are going to factor that product, and we need it to add together to be the b term. So find factors of the product AC that add to the b, or the middle number. So we need factors that add together to give us this b in the middle. So this b in the middle is going to be what they have to add to b. And that really is the only thing new here. So once we find the two numbers that multiply to give us a times c and add to give us the b number, then we just go ahead and we split the middle term. So we split the b, or the middle term, using the two factors. So that is what we were doing up here, where we turned negative 5x into negative 8x plus 3x. And then we're going to use factor by grouping, just like we did in the previous lesson. We're going to use factor by grouping to write the four terms as a product of binomials. Product of binomials is what we started with in this example up at the top, where we have two binomials multiplied together. And then if we ever want to check our work on these problems, we can always multiply everything back out. So the beauty of factoring is that we already know how to multiply polynomials, so we can go backwards to make sure that we did everything correct. But the real key here, because we already learned factor by grouping, is we need to multiply the a and the c, factor that term to find two factors that add to be the b term. So let's go ahead and practice. Example number 1. We have a standard form of x squared plus 8x plus 7. What that tells me is that the a is 1. Okay, there's an invisible 1 in front of that x squared. The b is 8, and the c is 7. So now what I'm going to do every time is I'm going to make a little t-chart. A t-chart just looks like a big letter T. Oops. Where in the top left, I'm going to multiply a times c. So in this problem, a is 1 and c is 7, so a times c is just 1 times 7, which is 7. Then in the top right, I'm going to put the b term. In this case, the b term is the 8 in the middle of the problem. And so now what we're going to do on the left side of this table is list out every combination we can think of that multiplies to give us 7. But it has to only be two factors. Because 7 is prime, there's not a lot of options here. So we could do 7 times 1 gives us 7, but we could also do negative 7 times negative 1 gives us 7. Those are the only options though, because 7 is a prime number. So now on the other side, we're going to check what they add to be. So 7 and 1, if I do 7 plus 1 on the right side, this adds up to be 8. And if I do negative 7 plus negative 1, that adds up to be negative 8. What we are looking for is the two numbers that add together to give us the b term. So because that first combination, positive 7 and positive 1, gave me 8, and 8 is my b term up here, that means that I'm going to choose 7 and 1 as my two numbers that I will use to split the middle. All the hard part is done now. Okay, so the hard part is figuring out what two numbers to use, which in this case is the 7 and the 1. Now we're going to go ahead and split the middle. So to split the middle, you take the original problem, x squared plus 8x plus 7, and you split that b term into two terms. So notice what I did there. I left the x squared in the front, okay, same x squared as before. I left the 7 in the back, same 7 as before. But instead of writing 8x in the middle, I'm going to write two terms that add together to be 8x. And I don't have to think anymore about what those terms are because I already found the 7 and the 1 over in my table. So I can go ahead and now split my middle to be 7x and 1x. Notice 7x and 1x add together to be 8x. And we already know that 7 times 1 multiplies to be 7, which was the AC term. So just to be clear, this 7 and this 1 are coming directly from this table over here. All right, that is the split in the middle part. Now all we have to do is perform factor by grouping. So if you want a full review on factor by grouping, then we did it in the last video. But essentially the steps are you divide the problem in half with a little vertical line. We're going to pull the GCF out of the first two terms, which is x in this case. That gives us an x plus 7 left behind. And from the right side, they have nothing in common, x and 7. So whenever they have nothing in common, I pull a 1 out. And technically, I don't have to pull that 1 out, but writing the 1 there reminds me that in the next step, I'm going to take the 2x plus 7s and factor those to the front. And I'm going to leave behind the x plus 1, where the x and the 1 were the coefficients in front of the two sets of parentheses. But notice those last two steps are purely factor by grouping. All right, number 2, we're going to go a little bit faster this time. So we're going to start by making a t-chart. Every time the t-chart is how we will stay organized. In the top right, we're going to multiply a times c. So a times c in this case is 5 times negative 4, which is negative 20. The b term is going to go in the top right, and that is negative 8 in this case. So now I will list out pretty much everything I can think of that multiplies to give me negative 20. Notice because it's negative, that means one of my two numbers will have to be negative. So I could either have 20 times negative 1, almost forgot the negative there, or I could have negative 20 times positive 1. If I add each of those together, 20 plus negative 1 gives me 19, and negative 20 plus positive 1 gives me negative 19. Notice that neither of those add up to be negative 8. So neither of those are the correct selection of numbers. Next things I can think of that multiply to give me 20 are negative 10 and positive 2, or positive 10 and negative 2. If I add each of those up, negative 10 plus 2 gives me negative 8. And oh, look at that. That was the number I needed. So once you find the number that works, you do not have to keep listing anything. Once we get something that adds together to be our b term, then we know that the two numbers we need are the ones on the left right here, negative 10 and positive 2. So now I'm going to split my middle term. Usually I do not write a separate line the way I did in the first one. So in the first problem, I wrote the a, b, and c here, but normally I go directly to splitting this negative 8x in the middle to be negative 2x, or sorry, negative 10x plus positive 2x. So normally I draw two little lines out of that middle term. The negative 8x is really just negative 10x plus 2x. And then I write the other two parts of the problem around it. So the 5x squared in front and the negative 4 in back. Now we're going to go ahead and do factor by grouping. So for factor by grouping, we divide the problem in half, pull the GCF out of the first two things, which in this case is 5x. That's going to leave behind x minus 2. Pull the GCF out of the second two things, which is a 2, and that will also leave behind x minus 2. And then I pull that x minus 2 to the front, and I leave 5x plus 2 behind in the back. All right, you go ahead and try the next one, and then we are going to have plenty more examples for us to work through, all with different little circumstances to them. All right, hopefully you took a second to try that next one. So now for the you try, all of these I'm going to start the same way by making a little t-chart. In the top left, a times c in this case is 2 times 4, which is 8, and the b term is negative 9. I need two numbers that multiply to give me 8, but add to give me negative 9. And this is a good example because notice the AC term is positive and the b term is negative. Whenever the b term is negative, but the AC term is positive, that means both of your numbers will have to be negative. Because the only way you can get a positive from multiplication is by multiplying either two positives or two negatives. But in order to get a negative over here for the b term, we're going to need both those numbers to be negative. So we can go ahead and start trying things that multiply to give us 8. And again, I need them both to be negative. So I could try -8 and -1. I could do -4 and -2. And well, that's it. So if I start adding these together, -8 plus -1 gives me -9. -4 plus -2 gives me -6. And I could have stopped after the first one, because once you get -9, which is the b term in this case, then you have your two numbers, -8 and -1. So now I can go ahead and split my middle term. -9x is going to split to be -8x minus 1x. And then I write my first two terms, or my first term in the front and my last term in the back. So now we do factor by grouping. I'm going to split the problem in half. The first two terms, I can pull a 2x out, which leaves behind x minus 4. The second two terms, we have a negative in front of the x. Remember, whenever there's a negative on the first term, you're going to automatically pull out a negative number. So I'm going to pull out a -1 in this case, and that'll leave behind x minus 4. Now that x minus 4 comes to the front, and we leave 2x minus 1 behind. Whenever that middle term is negative, that tends to give students the most trouble. So just be careful. Whenever you have a negative in the middle here, you're always going to have a negative that you're pulling out for that GCF in the next step. All right, problem number 3. We're going to make a t-chart. A times C is 1 times -12, so that's -12, and the B term is 4. Notice in this case, my AC term is negative, but my B term is positive. When you're in this situation, where AC is negative and B is positive, you're going to be multiplying two numbers together where one is positive and one is negative. Because it's a negative AC term, that means one of the two factors has to be negative. Because it's a positive B term, though, that tells me the bigger number has to be positive and the smaller number will be the negative one. So although I might try to multiply to get -12, I might try -12 times 1 and +12 times -1. I know that the first combination automatically won't work because the bigger number is negative, so there's no way -12 plus 1 will add together to be a positive number. Notice I get -11 over there, not +4. So I really only need to try combinations where the bigger number is the positive one. In this case, though, 12 and -1 also do not work. So then I might try 4 and -3, where notice I tried +4 and -3 because I need the bigger number to be the positive one. If I try to add those together, though, 4 plus -3 gives me +1. That's a little bit too small. Okay, so now a little bit more intuition for you to help build up experience. Notice that when the two numbers I choose are far apart, 12 and 1 are far from each other, when I add them together, I get a big value over here, -11. When I choose two numbers that are really close together, 4 and -3 in this case, I get a really small number when I add them together, such as 1. My B term is 4, which is between 11 and 1. So that means my two numbers need to be closer together than 12 and 1, but farther from each other than 4 and -3. So this is just a way to help guide you when you have a lot of options of things you can choose. In this case, we're going to end up choosing 6 times -2. And 6 plus -2 gives us 4. So that is our magic number. Okay, those added together to be the B term. And so we will choose 6 and -2 to split the middle with. But again, as you're guessing numbers, you shouldn't just be guessing randomly. Use some intuition. If the B value is small, like 4, then you're going to want to choose two factors that are relatively close together. But if the B value was really big, like in the previous problem, we had a big B value, -9, then you're almost always going to be choosing two numbers that are really far apart. In this case, -8 and -1 are as far as we could get. All right, that being said, we can go ahead and split the middle now into 6x minus 2x. We are in a situation again where we have a negative number as the coefficient for that x term on the second half. So when I factor by grouping here, I split the problem in half and I pull out an x from the first set of parentheses or from the first group. But on the second group, because it's a negative 2x, I'm automatically going to pull out a negative number. In this case, I'll pull out negative 2, and that leaves behind x plus 6. But again, I knew I was going to have to pull out a negative because it was negative 2x there. We will automatically pull out a negative number when the first term has a negative coefficient. All right, now I can go ahead and pull the x plus 6's to the front and leave behind the x minus 2. All right, plenty of more practice on the next page. Please try each problem before I go over it, because that is how you will learn best, is by practicing before I show you. You now have the skills to do all of these. There's just a couple little differences between some of them. So first little difference. Number 4, we have 2x squared plus 2 plus 5x. Before you start doing any of these problems, you need to put into standard form. Okay, so before beginning to solve anything, put it in standard form first. So this one we will rewrite as 2x squared plus 5x, then plus 2. If you don't put it in standard form, then you might confuse what is the a term, what is the b term, and all that good stuff. Now we're going to proceed as normal. We're going to make a t-chart. A times c is 2 times 2, which is 4. The b value is 5. Notice that the b value is bigger than the ac term. So because the b value is bigger than the ac term, 5 is bigger than 4, the first numbers I'm going to try are 4 times 1. Because when I choose two factors that in this case are both positive, and they're as far apart as possible, that'll give me as big of a result as possible. And if I add these together, I do in fact get 5. So you can always try other terms, but you want to use some kind of intuition when you're picking. I knew right away when I saw that the b term was bigger than the ac term that I wanted to choose two factors that were as far away from each other as possible. In this case, those factors were 4 and 1. All right, so now we're going to split our middle into those numbers, 4x and 1x. I'll write the first term in the front and the constant term in the back. I'll draw a line down the middle to do factor by grouping. I can pull a 2x out of the first group, leaves behind x plus 2. Notice the second group already is x plus 2, so I'm going to pull out a 1, which doesn't change anything, but it reminds me that in this next step, when I pull the x plus 2 to the front, I have 2x plus 1 left behind, where a lot of students, if they don't write this 1 here, will forget to put the 1 in the next step. So I like to write the 1 every time, just keeps me on track. All right, number 5. In this one, it looks like it's in standard form already because it is, but one rule that we need to remember is whenever we're factoring, we always want to check for a GCF first. So I'm going to write always check for GCF. Because if we try to do the process of the AC method right now, it's going to be harder than it needs to be because all of these terms have something in common. In this case, 8, 10, and 2 are all divisible by 2, and every term has an x in it. So I'm going to pull 2x out to the front. That'll leave behind 4x squared plus 5x plus 1. And now I can proceed as normal. In every step I do, though, I'm only focusing on this 4x squared plus 5x plus 1. I'm essentially going to ignore the fact that 2x is there, and I'm going to be rewriting it in every step. Okay, it'll be in the front the whole time, but everything I'm doing is going to be focused on the trinomial that we have there. All right, so now based on that, in that trinomial, we have an a term of 4, a c term of 1, so ac is just 4, and our b term is 5. Notice those are the exact same numbers that we had before in the previous problem. So I already know that 4 times 1 is going to work, and 4 plus 1 is in fact 5. So I know that these add up to be my b term, and they multiply to be my ac term. So now I can go ahead and split 5x in the middle to be 4x plus x again. In the front, we had 4x squared, and in the back, we had 1. Notice that the 2x that was in front, I haven't touched it all yet. Okay? everything I'm doing right now is inside of those parentheses where I underlined in blue. So I need to keep parentheses around all of this and then put the 2x in front in every step. So now I'm going to do the factor by grouping terms, or the factor by grouping process. So I'm going to split this into two groups by putting a line down the middle. The first group, I can pull a 4x out of to leave behind x plus 1. The second group is already x plus 1, so I'm just going to pull a 1 out and still leave behind x plus 1. But again, notice the 2x that's in front, I haven't written down yet. Everything I just wrote down is in parentheses, and the 2x is in front. Okay, now in the next step, I pull my x plus 1 out. That leaves behind 4x plus 1. But again, all of this is being multiplied by the 2x, so I can go ahead and put the 2x in front. Now, it's not wrong if I put parentheses around the x plus 1 and the 4x plus 1, because those parentheses are the same ones I had before. But in this case, I don't actually need them anymore because I already have everything factored on the inside. So these blue parentheses, although technically they fit what we needed before, we don't actually need them once we finish factoring, because this 2x that's in front is now being multiplied times the x plus 1 and the 4x plus 1. Whereas before, if I didn't put these parentheses in the previous line, then the 2x would look like it's only attached to this front term here. And it wouldn't look like it's being distributed to everything. But now that the inside is factored, now the 2x is automatically being distributed, because if we were to multiply all this out, we would distribute the 2x in the process. We would multiply our two binomials together to get what's in parentheses over here, and then we would multiply by the 2x afterward. All right, moving on. Number 6 is a little more complicated. Not in terms of what we're going to do, but it just feels more complicated. It has an xy in the middle and a y squared in the back. We're basically just going to pretend that that letter y doesn't exist for a second. So the a times the c is still 3 times 2, which is 6, and the b is still 7. I'm going to find two numbers just like before. In this case, 6 times 1 is going to add together to give me 7. So 6 and 1 are my two numbers. Okay, they add up to be the b term, and they multiply to be that AC term. But the only difference is that now when I split the middle, I'm not going to be splitting it into 6x plus 1x, because I need what I write down to add up to be 7xy. So I'm going to split it into being 6xy plus 1xy. Okay, and then I still have 3x squared in front and 2y squared in the back. So notice all I had to change was I just put an extra letter y on those two middle terms. Because again, 6xy and 1xy need to add together to be 7xy. All right, now we're going to proceed with factor by grouping as normal. So I draw a line down the middle. The first group I can pull a 3x out of, which will leave behind x plus, and be careful, don't forget the y, it's x plus 2y. The second set of parentheses, or the second group I should say, have a y in common. So I'm going to pull a y out, which will leave behind x plus 2y again, because y squared, when I pull that y out, just becomes 1y. Now I can move the x plus 2y to the front and leave 3x plus y in the other set of parentheses. So the process really is the same. It just felt a little bit harder at the beginning because that letter y was there. But notice that letter y just fits right into our AC method process. We almost were able to just ignore it. All right, next one. We have negative x squared plus x plus 20. If you haven't paused yet, please take a chance and try this for yourself. All right, hopefully you paused. So I'm going to proceed as normal, where I'm going to multiply a times c, which is a negative 1 times 20. So I get negative 20. The b term is just 1, because it's only 1x there. I need two numbers that multiply to give me negative 20 and add to give me 1. So notice that we have a negative AC term, which means one of my two factors will be negative and the other will be positive. And my b term is very small. Okay, it's only equal to 1, which means that my two factors are going to need to be really close together. So if I tried any two factors, I might try negative 20 times 1, but those are really far apart. So when I add them together, negative 20 plus 1 is negative 19. That's way too big of a number. Okay, so instead, we want to try factors that are close together. In this case, I might try -4 times 5, but if I add those together, I'm going to get, oh, wait, look at that. I get +1. If you had tried -5 and +4, you would have gotten -1, so you would have been real close. But in this case, -4 and +5 add up to give us 1, and they multiply to give us -20. So we will split our x term in the middle as -4x plus 5x. Then we have a -x squared in front and a +20 in the back. We're going to divide this problem in half to do factor by grouping. I can pull a -x out of the front to leave behind x plus 4, where notice both things change signs because I pulled a negative out. I can pull a 5 out of the second group to leave behind x plus 4 again. That x plus 4 comes to the front, and we have -x plus 5 left behind. So same process, the only real difference there was we had a negative number in the front. All right, number 7. We have 5x to the fourth plus 12x squared plus 4. Now, what might seem harder about this is it's x to the fourth and x squared, but it's actually not going to affect our process at all, other than it'll be like number 6, where in number 6 we had this xy in the middle, so we split it each term to be xy. Here we have an x squared in the middle, so when we split it, both of these will have x squared in them. But the way we figure out what numbers to use is exactly the same. Make a t-chart. 5 times 4 is 20. The b term is 12. If I choose two numbers, I might try 20 times 1, but that adds up to be 21. That's too big. I might try 10 times 2. That adds up to be, oh, look at that. That adds up to be 12. So 10 and 2 are my two magic numbers. Notice, by the way, that I don't always know the right combination immediately. Sometimes you have to actually try a couple until you find the right combination. All right, now we're going to split the middle term into 10x squared plus 2x squared, where notice this is the unique part of the problem. Because I had an x squared in the middle, both of the things I split it into have x squared on them. Now the rest of the process is the same. 5x to the fourth goes in front, and +4 goes in back. Let me fix my exponent on that 5x to the fourth real quick. There we go. I'm going to split it down the middle. The first group I can pull 5x squared out of to leave behind x squared plus 2. The second group I can pull a 2 out of to again leave behind x squared plus 2. I pull that x squared plus 2 to the front, and I leave behind 5x squared plus 2. Lots of 2's in that problem. Now, whenever you get something that is nonlinear as a factor, you always need to make sure it doesn't factor farther. So in this case, there's nowhere else we can go. But hypothetically, if this first term here was still factorable, I would have to continue factoring in order to be done with this problem. So x squared plus 2 does not factor any further, and 5x squared plus 2 also does not factor any further. But if they did, we would keep going, okay? Because we know how to factor quadratics, because that's mostly what we're doing right now. All right, number 8. This one's back to being a pretty easy one. We are going to try to find two things that multiply to give us 1 times 7, which is 7, and add to give us 3. So I might try 7 times 1, -7 times -1, and when I add those up, 7 plus 1 is 8, -7 plus -1 is -8. And then I start to wonder, what did I do wrong? Because I can't think of anything else that multiplies to give me 7. Well, I'm not wrong. Okay, what's happening here is that this is not factorable. Okay, this is a prime quadratic. What prime quadratic means is quite simply not factorable. Okay, when we say something is prime, we just mean that it is not factorable into smaller pieces. So when you get a prime quadratic, we don't do anything. We are done with this problem. Now, in this case, we figured out it was prime by trying every combination we could think of to multiply to give us 7, and none of them added up to be the b term, which was 3. In the future, all right, so a little note here, in the future, we will use the discriminant. So D, got to remember how to spell here. Discriminant. Okay, in the future, we will use the discriminant, which is b squared minus 4ac. Okay, we will use the discriminant to decide if something is factorable. Specifically to decide if a quadratic is factorable. So now we won't go into all the details of what the discriminant is right now. That's for a future lesson. But in this case, if we found b squared minus 4ac, let me do this in a different color. Okay, b squared minus 4ac in this problem would be equal to, the b is 3, so b squared is 9. And then negative 4 times a times c is negative 28. So we would have 9 plus 28, and this is equal to 37. The reason this is not factorable is that the discriminant right there, okay, this 37, is not a perfect square. So in order for a quadratic to be factorable, the discriminant needs to be a perfect square. And in this case, we get 37, which is not. You don't need to know all that yet. Okay, our process of trying to make a t-chart and failing already told us that this is not factorable. But sometimes you want a better, or at least a more formulaic way to determine these things. So specifically, the discriminant in the future will be how we decide if something is or is not factorable. And in this case, again, 37 is not a perfect square, so the discriminant tells us that this is not factorable. All right, now let's do a hard one. That one looked innocent, and then it ended up being challenging. But number 9 is just legitimately challenging. So first thing, no GCF. We check 25, 40, and 16, can't pull any numbers out. So then we make a t-chart, and we proceed as normal. 25 times 16 is 400, and the b term is 40. Notice that 400 is very large. So we might just start trying things and hoping that it works and failing. So I might try 400 times 1, but 400 plus 1 equals 401. That doesn't work. So then I might try 200 times 2, and 200 plus 2 equals 202. Still doesn't work. Notice though, 401, 202, my numbers are getting closer to 40. All right, so let's try 4 times 100, because 400 is not divisible by 3, so I try 4 instead. 4 plus 100 is 104. Still not small enough, but we're getting closer. Then we might try 5 times 80, where 5 plus 80 equals 85. Still not small enough. So then we might try 8 times 50. 8 plus 50 is 58. Hey, we're getting closer. We're almost to 40. So how about 10 times 40? Well, 10 plus 40 equals 50. Still not right, but we're still getting closer. And there might be some things in the middle that work, but I would jump all the way then to 20 times 20, where 20 plus 20 does equal 40. So we found the numbers that work. Notice though that that was not trivial. I had to try a whole bunch of numbers, a whole bunch of combination of factors before I found what worked. There is absolutely nothing wrong with that. All right. You can try as many things as you want until you find what works. And all I did was I kept increasing what I was dividing by. So I divided by 1, that combination didn't work. So I divided by 2, that combination didn't work. I tried to divide by 3, but 400 is not divisible by 3. So then I went to 4. Then I went to 5. I tried 6, but it's not divisible by 6. I tried 7, it's not divisible by 7. So then I did 8. Then I tried 9, that's not divisible. So then I tried 10. And you keep going and going until you find the combination that works. But notice, I'm not just randomly making things up. I'm increasing what I'm dividing by. 1, 2, 4, 5, 8, 10, all the way until I got to 20. So it is not about who can get there first. It's about who can get there. And although it took us a while, we did in fact get to 20 times 20, which did give us the combination that worked. So now we proceed as normal. We're going to split the middle into 20x plus 20x. The first term is 25x squared, so I put it in front. The last term is 16, I put it in back. We split the problem in half. GCF of the first two terms is going to be, in this case, 5x. When I pull that out, I leave behind 5x plus 4. The second group, I can pull out a 5 also. Oh, nope, sorry. I can pull out a 4 from the second group. That leaves behind, again, 5x plus 4. I pull the 5x plus 4 to the front. And coincidentally, I have 5x plus 4 left as my second factor. In future classes, you might learn that this was a perfect square trinomial. By that, what I mean is it factors to be 5x plus 4 times 5x plus 4, which we can write as 5x plus 4 squared. And we actually have a very quick way of determining if this is the case. The first term is a perfect square, and the last term is a perfect square. And that tips you off right away that you are likely in a perfect square trinomial situation. For the purposes of learning the AC method, everything we just did here was perfect. But we will at some point, maybe not in this class, but in a future math class, learn that there was a shortcut where we could have gone directly from the start to this bottom piece without ever actually having to do this table on the side. So sometimes there are shortcuts. In this case, there was one. Okay, I could have looked at this problem and done it in 2 seconds just because I know the formula that gives me the shortcut. But you got to learn the hard way first. And in this case, the AC method works. So even though we know that there is a better way, we can still get to the answer doing it this way. And why learn a million different ways to do things when you should master the original strategy first? So make sure, practice the AC method before we worry about tricks to get us to the answers faster. All right, one more problem. If you haven't paused yet, please give it a try. But all right, what we need to do is multiply a times c, which in this case, 24 times negative 15 is negative 360, and the b term is negative 2. In order to get negative 360, I need to multiply negative times positive, and I'm going to skip right to what works in this case. It's either going to be negative 18 times 20 or positive 18 times negative 20. If we try each of those, negative 18 plus 20 adds up to be positive 2, so it's not that one. 18 plus negative 20 gives me negative 2, and so that is our winning combination, where remember, if you can think of what it was going to be that quickly, then you just keep trying things that multiply to be 360 until you find what works. So just keep dividing by bigger and bigger numbers. Divide by 1, then divide by 2, then by 3, then by 4, so on and so on. All right, once we have the numbers that work though, we can split negative 2x into 18x minus 20x. I'll throw the 24x squared in the front and the minus 15 in the back. Divide the problem in half. The first group, I can pull a 6x out to leave behind 4x plus 3. The second group is negative, so I'm going to pull out a negative number, and in this case, a negative 5 is what I can pull out. That'll leave behind an x plus 3 again, where be careful with the negatives. That negative 15 became positive 3 because I pulled a negative 5 out. And, oh, forgot to write the 4, so let me fix that. It's negative 5 times 4x plus 3. My apologies. We're going to pull that 4x plus 3 to the front, leave behind 6x minus 5, and you are now, hopefully, ready to conquer the AC method practice problems. So thank you for joining me on this journey. I know this one was a lot of fun for you, and I'll see you for the next one.